Okay, welcome back, physics fans. Here we are on question number 9 on the collisions worksheet on one-dimensional momentum. Physics 11, one-dimensional momentum. We have a 150 gram coffee mug that is going at 20 meters per second. Brutally fast, that's about 72 kilometers an hour. When it collides with a 200 gram Gumby doll going 4 meters per second west. So they are headed in the same direction. So this is kind of like one car bumping into another car, rear-ending it, okay? The doll ends up going 12 meters per second west after the collision. So this is a collision. So instantly on a collision, we write down the momentum before equals momentum after. And if you just go P equals P prime, I'm fine with that. That's the momentum. And there's two objects, so m1v1 plus m2v2 is equal to m1v1 prime plus m2v2 prime. You lose marks on your formulas and showing your work on quizzes and stuff like that, then pay close attention. This is what I want you to start with. I want you to understand that it's a conservation of momentum in a collision. When it's two objects, this is the formula. So you need to put these down. Then it goes to how does it affect on this question? Well, I'm going to start just filling it in because there is no shortcuts on this one. So this is going to be 0.150 kg moving at 20. And I'll put a west there. Plus the Gumby doll, which is 0.2 kg. And it's moving at 4. And it's west. Okay, I'm just going to move this to the side. I want to line up my equal signs. And that equals the mass of the doll. So you know the doll, the Gumby doll. So we don't know the mug. So the mug is 0.15 kg. And I'll do it in red for the unknown. Plus the mass of the Gumby doll, which is 0.2 kg. And it's moving at 12 meters per second west. 12 meters per second west. Okay, so there it is. There's in this formula, there's 6 variables, and we were given 5 of them. Okay, 4 of the ones are highlighted, and there's my 5th one. So there's 5 numbers highlighted in the question above. So you just have to plug it all in and solve for the one unknown. So it's 0.15 times 20, and that's going to be 3 kilograms meters per second west, plus 0.2 times 4 will be 0.8, 0.8 kilograms meters per second west, and that has to equal this. So I'll just say copy that down, and then 0.2 times 12. So 0.2 times 12 is going to be 2.4. So this is 2.4 kilograms meters per second west. So everything's west, so we're doing okay here. We don't have to change anything from positives to negatives because they're not going in the opposite direction. Let's learn that idea. They're all wests, so we don't have to change them to east so that we can work with it. And negative. So this is going to be 3.8 kilograms meters per second, and it's still west. And that is the total momentum of the system before the collision. So that's going to be the total momentum of the system after the collision is 3.8. Okay, if this is 2.4, so we have to subtract 2.4 from both sides, and we get 1.4 kilograms meters per second west is just going to equal this 0.15 kg and VI prime, V1 prime, sorry. So this is 0.15. This is actually, I'll just go dot, 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 dot. Just bringing that all the way down. And then let's solve for VI prime, V1 prime, sorry. So it'll be 3.8 subtract this number above is the 1.4, and then we divide that by 0.15, and we get the velocity of 9.333 meters per second west. Okay, that's a lot of work there for that question. Now, calculate the doll's change in momentum and then calculate the mug's change in momentum. So the doll, we have that it's going 4 and then it's going 12. So its change in momentum of the doll is mass times the change in velocity. And this is of the Gumby doll. So its mass is 0.2 kilograms. And this is just going to be VF minus VI. So VF is 12 meters per second west minus 4 meters per second west. And let's emphasize again, these are both west, so we can just subtract them. In a lot of collisions, to make it difficult, I make it change direction, and people don't catch that. So if it does change direction, then you would actually have to add them. So this is going to be 8 times 0.2, and that means it's change in momentum. 0.2 times 8. So its change in momentum is 1.6 kilograms meters per second west. And the last question is, what is the mug's change in velocity? This is for the mug. Its change in velocity, its change in momentum, sorry, is mass times the change in velocity. And its mass is 0.15 kilograms. And its final minus the initial, this is going to be interesting. Its final is 9.333 meters per second west. And its initial is 20. So if I subtract those, I get this number up here, and I subtract 20 from it, and then I multiply it by 0.15, I get exactly negative 1.6 kilograms meters per second west, which would be better written as 1.6 kilograms meters per second east. So the change in momentum of one object has to equal negative the change in momentum of the other object, and it proves out that it does. Why is that? Because momentum is conserved. As one gains momentum, the other one has to lose momentum. There we go. That's the good question. If we had to have a added question to it, D, if the collision took so much time, what was the force of impact? And we could do that because its change in momentum is also the force times the time, the impulse. So if I give you the time, you can calculate the force. If I give you the force, I can calculate the time. And what's really cool is we're calculating the force here, and we're not using acceleration. Okay, we're not using Newton's second law. Well, we are. It's in the formulas here, but we don't see it. Anyways, there we go. Thank you very much. Enjoy.